Joining our Color Live seminar again. And today, it's a great honor to have the Yoav with us. And Yoav Bressler, it's just brief introduction, Yoav, right? Yoav Bressler received a master in the department in the School of Engineering in the Tel Aviv University, Israel. And his interest is color technology. Start from 1988 at working with both a very large company, including Kodak and Hewlett Packard, and a small startup company. Since 2007, Yoav has joined the Stratasys and working for the UV curable inkjet printer, and now it's a 3D polyjet full color 3D printer, right? Yo, I believe we met each other in the color imaging conference in the Darmstadt, possibly 2016. And
Yes.
yeah, so we work very closely and yeah,
Yeah.
very happy to work with you.
Yeah, thank you.
Okay.
Yeah, time passes. Okay, so I
Yeah.
will share the presentation.
Yeah.
So this is a retrospect, or looking back at the lecture that I gave actually in Linz. There was the Linz conference 3 years ago. And I came and talked about something that was very much in the future then. And it's nice to look back at it and see what kind of progress have been made in the last 3 years in the subject. So the subject is basically our project technology, and specifically the application of it to color and textiles. Let's see if I can move this. Okay. So the content. At first, I will introduce you to the technology, and then I'll start as I was describing, as I was looking forward 3 years ago, and then what the status is today and how we perceive the market. And already you see in the slide, you see first application, something that looks like an embroidery on some textile. So PolyJet technology. Here I have a movie, and I hope the movie works. Okay. Has the movie gone well? Have you seen the movie well? Is there any way of getting feedback from this format? Anybody can answer if you've seen the movie, if it went well.
Yeah, if people have any comments, you can put in the chat, right? They cannot talk directly.
Okay, did it work for you, kinda?
Yeah.
Okay, so I'll go on. So, describing the polyJet technology, it is divided into the following stages, and let's go over them one by one. First of all, slicing. Slicing is the logical or software operation that's starting from some kind of a CAD file or source file that describes what you want to print. Usually you convert it to some kind of a mesh, and then you slice it in slices because the printer will print things slice by slice. And concentrating about the business of fashion, it's an interesting question is what is a CAD file in this market? How do we get our input? If somebody is designing a dress or some accessory or maybe a bag or a hat, what is the source of a file that I get at source and then I convert to mesh and then I print? It's not a simple question. It's all very much at the beginning stage, and actually I will very much appreciate input on this question. Okay, going on to jetting. This is an inkjet technology. So one jets liquid material downward onto a tray. And the liquid material is the photopolymer. And there is a scanning operation in two directions, in X and Y, or sometimes it is a radial movement in the desktop printers that we also make. And since this is a photopolymer, it will solidify after being injected. Another way to explain it, you have printing heads or jetting heads, and they're making a scanning movement in both X and Y. And you jet the liquid downward, and you build some kind of a model layer by layer. Here you see that the model is painted in yellow and white. And this is to signify that there is one material that is the payload material, what is going to be left after the cleaning process. And there is a matrix or surrounding of a support material that will need to be removed. This is the usual case in 3D printing. And one prints layer by layer. Here's another schematic representation. You see you have several print heads. In our case, every print head prints in a different color. And there are also UV lamps to cause the photopolymerization of the liquid to turn it into solid. And the model is creating standing on a tray, layer by layer, so the height is incremented after every layer. Another view of it, concentrating on the step of UV curing. You have the printing heads, and again, there is a printing head for every different color, every different resin, or every different property of resin, and you have sources of UV light. The model is built layer by layer, and depending on the speed or accuracy that is desired, you can have 60 micrometers to 30 micrometers layer thickness. Again, usually, there is the payload model material that you print to make your model, and it is surrounded by a matrix of support material. The support material is usually cleaned in a post-production process. You clean it with a project water jet, or you maybe if it's water soluble, you just immerse it in a bucket of water and it dissolves. Important note here that usually we are not using support in the fashion business, because usually we print in a sort of 2.5 printing process when you build a model on top of a textile, and usually you don't need to support it by anything. So usually you don't need to clean the support material after the printing. Okay, the benefits of the technology is high resolution and high accuracy of dot placement, and it produces smooth surfaces. The accuracy is higher in the Z direction, in the direction of the height of the thickness of the layer. Again, benefits of the technology, the ability to print very thin walls, which translate to small items or delicate items when you print on top of textile. High enough building speed, especially if you're not building very high models, if you're just printing a few layers, as it happens when you print on textile. And also ease of use. Generally, the technology is used in many, many different industries. And in this presentation, I'm concentrated in one very specific application of the technology, which is printing on textiles. A comment about color. A benefit of the PolyJet technology is that it can print in real color. You have full control of color. You have also full control of transparency. And here you see the richness of colors that one can print with the technology. I will not give you numbers for gamut, but you see the many, many different colors that can be printed. When we're talking about the fashion industry, we have to raise this question. What is actually our requirement? How accurate do we need to be for a specific use? How repeatable do we need to be? And in a more fundamental way, how does color perception happen if one is looking at three-dimensional models printed on top of textile? Is the appearance judged the same way as in 2D printer, or is it a different experience altogether? Here you see a hint to an experiment that we are doing together with leads of printing color balls in different colors and trying to assess the human color perception in 3D printing. For the purpose of controlling color, we're using a off-the-shelf instrumentation and off-the-shelf software. For example, we have a color reading device from X-Rite and profile making software from X-Rite. And here you see a nice twist on it. You have a 3D printer jig in white that is aiding off-the-shelf X-Rite colorimeter to measure some samples. Also about color, you have to design a color management workflow. And specifically, you have to think about how does a color management workflow looks in the fashion business. One of the questions that you have to ask yourself, Are you going on the industry standard ICC workflow or maybe not? Pros and cons for that. Why go for ICC? Because it's plug and play. Because you can use some third-party profile maker, for example, from X-Rite. And there is a big workflow with the integration into Photoshop. Why not use ICC? Because we're actually selling a turnkey system. We're supplying the resin, whether they are hard resin like Vero or soft resin like the Agilus resins. We are supplying the hardware. We're supplying the software. And we can write our own color management system and protect our specific intellectual property. You can think about a compromise in the middle when you can use some third-party profile maker together with your own or integrated in your own special workflow. Okay, moving on, I would like to describe the world as it looked to me 3 years ago. We knew we had some prospects for printing on apparel, and we didn't really know how to do it. We had similar markets. In what way is a market similar? In that it is low volume, high quality, and end-use items. Low volume, in 3D printing at the moment, the technology is suitable for printing special one-off or low quantity models. If you want to print plastic in high quantities, there are the traditional plastic methods to do it much cheaper. And since you're making it in low quantities, then you have to sell items that have high value per each item. And what you see here is the market of art. These are one-off artifacts that have a very unique appearance of color and gloss and transparency. And we classify them as end-use items because it's something that goes to the end customer, and the customer is going to keep the item for a long time. This is in distinction for prototypes and models, that you prototype something else and then you throw away. We as a company were trying to move from prototypes. It's a good market, the market of prototypes, but we wanted to expand ourselves to end-use items, something that the end user will keep. So this is one example of such a market. More work that we were doing with various artists. And we were always looking at the fashion business. But at first, for let's say the first 15 years, we were thinking more of printing the dress rather than printing on the dress. And there were several attempts, and there are more classified as pieces of art, still bordering on the market of arts and museums. But starting to look at the fashion business for dedicated items. Here's another example, not in color, but this example works because our resins are flexible. We have hard plastic resins like the Vero series, and we have soft, pliable plastic, rubber-like plastic like the Agilus series. So you could think about some piece of garment that is made of these resins. Tell you the truth, it wasn't very comfortable to wear. Okay, so that was the situation in 3 years ago, in July 2019. What is the news? The news is that we're printing on the textile rather than printing instead of the textile. And for that, we have devised a new detachable tray. Here you see a picture of the printer. In the background, you can see the printing heads and all the electronics, and the foreground, you have a tray, and a piece of textile is wrapped on the tray. It is held in place by a frame, and the frame is held tightly in place by magnets. And you can see that there is space to fold the garment under the tray. The tray will go up and down as you put a 3D shape, but still there will be always a space for the textile underneath. At the top right, you see how it works. You have the top bit on which you put the garment, and you have the bottom area into which you fold the excess textile. At the lower left, you see the mechanical breakdown of the detachable tray. The benefit of this tray is that you can always load the next cloth on one tray while the printer is printing on another tray. So you have two of those. One is always in the printing being printed on, and the other is outside of the printing, and you are busy arranging your textile on top of that other tray. And this is because the utilization of the printer is very important. Even though you're printing in low quantity, you still want to print a few thousands of items, and you have to keep the printer always busy. Another trick that you can do with the detachable tray is that you can put it on top inside of some kind of a viewing booth. There is some kind of a box or a cabinet, and there is a camera on top of the cabinet, and the camera is looking at the tray, and it's looking at the piece of cloth that is wrapped on the tray. And there is one such viewing booth per many printers. It's something that you have online at an installation. And the reason that you need this alignment station is that you can capture the existing arrangement, the existing pattern that is already printed on the textile. Why do we need this alignment? Because if there is already something pre-printed on the textile, and we want to augment it, we want to print something on top of it, then you have to print the plastic exactly on the right location on top of a pre-existing pattern on the textile. One workflow is that you receive a pre-printed piece of cloth, you capture the pre-printed pattern, you present the pattern to the user, and then the user design the extra augmentation, the extra plastic elements on top of the existing 2D pattern that is already on the cloth. This means that the design software is a Stratasys application. Another possible workflow is that you receive the pattern via some kind of a CAD file. And I'm reminding you that the question is open. What would be a CAD file in this market? And then you put the cloth on the tray and you align the pattern on the cloth already placed on the tray. Again, I would very much appreciate later, maybe via email, some kind of a discussion of how this workflow may look to you. Another new twist that we added on top of the existing printers is the idea of a fabric analyzer. A fabric analyzer is a pattern that you print on top of a textile, and you do it per each job or each batch or per each season or each project, because each one is a new challenge. Every season or every project, you have a new cloth of different physical properties. Sometimes it's stretchy, sometimes it's not. Sometimes the adhesion of the plastic to the textile will be good, sometimes it will be bad. So you have this test pattern that you print and you measure how well our resins are accepted within that new kind of textile. And it measures the parameters such as the absorption of the resin into the textile, whether the adhesion is good or not, whether the details looks well enough, and all sorts of problems and issues that you might get in 3D printing. And then you make an assessment. Can you go on with the project on this piece of textile with this, or do you need to go for another kind of textile, or maybe another kind of pattern for a specific project that you're trying to devise? Okay, as you see, what we print is actually isolated pieces of plastic on top of the textile. And they can be rather long. Sometimes they're shallow, and sometimes they're tall. It's a unique property of our printer. If you compare it to other printers that print on textile, is that our patterns can be rather tall. And here you have a variety of examples. Sometimes the plastic will actually start to look like threads, being very, very narrow and tall. Sometimes it will be flat. Sometimes it will appear like embroidery or like jewelry attached onto the fabric. Sometimes you make a clever use of color, and sometimes you print in monochrome. Okay, this is another movie. There's another movie, I think. How many of them are there? I think this one is the one. So, okay, another one. Okay, I hope that you're beginning to see what kind of wealth of opportunities and design ideas you have with this printer. I hope you could see the play with colors, the play of colors against a three-dimensional shape, the use of the printing of micro lenses in clear resins on top of the color to add another three-dimensional effect to it. And the fact that you can also print flat elements. The design space is unlimited here. Now I would like to show you some slides from our marketing department. First of all, I want to make a comment about the interplay between three-dimensional shape, perceived three-dimensional shape, and two-dimensional printing. Try to imagine what kind of three-dimensional shape this bag has. Well, actually, in this bag, it's just an optical illusion. It's the print is simply two-dimensional, but the effect is three-dimensional. Freedom of manufacturability design from premium luxury good market. Again, we are aiming for the premium luxury good market. We're aiming for low quantity and the ability to make unique designs that cannot be made some other way. Well, this slide is full of numbers. I will just let it hang and I will not read the numbers to you. Suffice it to say that there is a claim that there is a market to that. And we have our hopes high in the future of printers within the market. Again, where we're aiming at is the highest of the market when you hardly ever go behind that 1,000 pieces or 10,000 pieces. What we can make is pieces of clothing. We have done already some interesting collaboration project with leading brands on the market towards bags and accessories. And we also have done some promises samples for footwear companies. Yes, although the tray is two-dimensional, there is a way that you can create a three-dimensional design on a three-dimensional pre-existing object such as a shoe. So I'm repeating, in the sub-market of footwear, usually the quantities are larger than, let's say, handbags. And also you have to print on top of a three-dimensional object, but there is a way of doing it in high quantity. So we already have, we are already playing with that. Okay, what do I see here? Is this a movie? Yes. Okay, what else is there? Okay, another show of design ideas. Again, I'm drawing your attention to the interplay between transparent plastic and color plastic. We have a control over that, so we can print clear plastic on top of the color plastic or any combinations of layers to create a stunning combination of visual effects. Okay, I think I'm getting to the end of it. How do I stop sharing?
Okay, thank you very much, Yo. Such fascinating
Yeah,
presentation.
any way to receive questions in this format, or
If anybody want to have a question or anything to discuss, can you leave your comments in chat? So we can see it. So then we can answer. You gonna answer, not we. Anyway, it's so interesting. When I hear it, I think lots of things. There are places for collaboration, and we are in the school of design and fashion industry, and most importantly, we will pass all the presentation to the people in our school, and I'm sure they will come back, good the feedback. From my perspective, from your presentation, first it's color, second appearance, and thirdly it's visual appearance. And certainly something we are very interested. And when we think about the visual appearance, even thinking about the tactile, because the Qingyuan, our PhD student working on the tactile property, especially the visual tactile. How can make it look soft? How can it make your fashion looks a little bit the tough, right? And that's certainly something we are very interested. And in terms of that kind of things, do you have anything considered or about visual tactile?
Well, as I said, we have two kinds of resins that we supply with the machine. We have the Vero range that is hard plastic.
Mm-hmm.
But we also have the Agilus range. And usually, when you print on textile, you want it to be a bit soft so it will fold very well.
Mm-hmm.
So we are working on the range of materials that are soft. It's not only that they look soft, that they are actually soft to touch. But controlling the tactile experience, I must say it's a very challenging task in 3D printing because you are limited by the properties of the resins are limited by the fact that you have to inject it through a nozzle, and it has to solidify with UV radiation, and it has to pass the strict standards for safety, and it has to look well. So getting the tactile experience on top of that, I must say it's not easy, not an easy requirement.
So that's so we are looking at the one that you mentioned. It's a real tactile, right? And another is a visual tactile. Then we found by changing the color, especially the texture, then you have the different feeling about the tactile. I think definitely that's something
Yes.
they to do for change the texture for you, right?
Yeah. This is something that I welcome. I will rather change the apparent feeling than the feeling itself, because the changing the appearance for me it will be much easier.
And in terms for the current technology, whether you can do for all different material, you can print all different material or not.
What cloth we're printing on? You mean?
Yeah.
Well, we are beginners here, and we haven't seen anything like the range of textile that exists in the market. So we try to print on one sample of cotton and one sample of polyester, just to make sure that we have it approximately right. But I think that I mean, that is my personal view. The way you go to market here is different than in any other 3D market. In a normal 3D market, you're supposed to bring a solution that already works for a specific use. And here, the range of materials and uses, just a minute, what is a textile? What is the use of a textile? The range is infinite. So the way I see it is it should be arranged more like a service. Is that at the beginning or before a season or before a specific project, then the customer will approach us and suggest that the project and suggest the textile. And this is why I mentioned the fabric analyzer. So you print a test print. And you see if you have good adhesion, if you have how the textile is responding to the print. And it's a process of negotiation. If it doesn't work well, you suggest to the customer maybe think about some other textile, and maybe you change the design.
Yeah.
And I think at the beginning of a season in textile, you have those you have a month for this for several iterations until you get to a design that you know will work.
Yeah, it's a more, I can say it's more the design perspective at the beginning, and later maybe you can continually working on other things like the functional tactile material, something like that. Yeah. Okay, I see there are some questions in the chat.
I don't see them, but
if you click the chat window.
Oh, okay, because I saw two of them. Okay. Okay.
From Qian Qian.
Okay, I had one comment. There is no sound in the video. I hope that worked for you. Was there sound in the video for you?
No, there's no sounds, but it's okay. So we can say it. Yeah.
Okay, the sound. Okay, yeah. And you're missing the very impressive sound, but okay. Can they be washed or dry cleaned? Yes, they can be washed. When I'm saying that the adhesion of the plastic to the textile is good, I mean that it can go through several washing cycles. How do I make the color look different from different directions? We're printing tiny lenses. We print at the bottom, we're printing some color. And then on top of the color, we print tiny lenses from transparent material. And that makes what we call the butterfly effect. That makes the color look different from different angles. It's the effect of the optical effect of the lenses that we print on top of the pattern.
Very interesting.
When you touch the 3D printing textile, okay. If you touch the 3D printed textile in the area where it was not printed on, just between the prints, then it feels like the real fabric. When you touch the printed bit, well, that depends. As I said, we have two kinds of plastic. We have hard plastic, and that will feel like hard plastic. But we also have the soft plastic, and it will feel rubbery.
Yeah, so you will feel like touch a plastic for sure.
You either feel like touching plastic or like touching a rubber.
Yeah.
If you make those, if you make bristles of rubber, it feels slightly better. So I would not necessarily call the touch pleasant. It's I won't classify it as pleasant. It's more in direction to be impressive than pleasant. But what I saw in one of the videos, you see that I was overturned the cloth, and when I overturned the cloth, you see that you don't see you don't feel the plastic on the other end. So when you're wearing it, the touch on your skin is still the original textile because it doesn't go all the way to the other side.
Yeah, that's what I think you will have a very big difference about real tactile feeling and visual tactile. From your video, for some example, it looks very, very soft, right? And but when you touch it, I guess it might not that soft. So that must be some trick you can play with.
Yeah, soft is a crude word because they're soft like rubber and they're soft like cotton wool. It's not the same softness, and it might be a gradation of softness qualities in there that we have not yet explored.
Very interesting. Does anybody else have any questions? No, we still have time. You can leave in the chat box. In terms of the color control, you have a slide to mention either you can use ICC or you can use your bespoke software. What's your opinion about it? How different they are? Whether if you do it your own, whether you can do a better job than ICC?
Well, that was meant as an open question because at the moment we haven't changed anything in our existing workflow. So we have the existing PolyJet workflow when you had a set of factory profiles. And you select your factory profile depending on the resins. And if you're really a very, very advanced user, then you can make your own profile. don't really encourage that. The question is first, the textile is first, what is the demand? Why not use a factory profile? In what workflow does it integrate? And how you will do your color control? And I still don't know enough about. I guess it's not even one market to speak of. I think it, as I said, it's more of a servant's mentality. I know that the way some people are working in the textile industry, that they will have a color book or mood sheet per each season. So what they will want to do is just print a few samples on the printer, and they say, okay, that is within my mood. This is within my design intent, and that might be might be enough.
Yeah.
I don't know if I really need to accurately replicate some given color.
Yeah. Comparing with the color dyeing, of course, your technique already make very accurate color control.
Mm-hmm.
Okay. Yeah. So I think yeah, there are lots of area, and your video will placed in YouTube, right?
Okay.
Also, we're going to share with all our colleagues. It has a scientist in the textile industry, different textile technology. I'm sure they will be interested and contact
Okay.
with you.
Just one last parting shot. I kept talking about a piece of textile that I print on as if it is before you make the garment, it is before stitching. There's also the possibility of printing direct on garment because you can fold the garment under the tray. For example, here I have a shirt, and at the back of the shirt, there is a 3D printing, so you can bring your own shirt and print a pattern on it. This is something that is a hit in a trade show. If you bring the printer to a head show, people will bring their own garments and you'll print on them. So this is just yet another possibility.